Hey 11, this is an introduction to exercise 5G on inverse functions on page 196 of your textbook. Now we've gone through inverse functions in the past, especially looking at when we have our logarithmic or our exponential functions. But today we'll be looking at the idea of applying the domain and range in our understanding of the inverse functions. Now you may well have already completed this in terms of our chapter 13 content, but this is just some extra revision before we move on to our next topic, which heavily involves the use of domain, range, and inverse functions. Now, a quick reminder that if a function is a one-to-one function, where we have a single x value being represented into or mirrored or imaged into a y value, then for each number y in the range of f, there is exactly one x in the domain of f such that f of x equals to y. Now, if you remember arrow diagrams, all that's saying is that for each value of y, so for each value of x, there is a single value of y. Let's use real numbers to represent this. Let's say 2 and 4. I know that there's a number there, and let's say the number 1 goes into the number 1 as well. Now all we know is that we're saying for each single x value there is a single y value, and if I go backwards, we know that applies the other way around as well. Keeping that in mind, if we switch the values, remember we find our values of x, or our functions of x or y, depending on actually flipping and switching out x and y values. And when we switch the x and y, the same thing occurs to our domain. And you can see on the right hand side of here we've got listed. The domain of our inverse function is the range of our original function. And the range of our inverse function is the domain of our original function. So we're switching the domain and range around for our inverse function. And the first thing we're going to do typically is actually just draw the graph we're more familiar with. Now with logarithms and exponentials, you're more familiar with both, you're sure, but in some situations, it doesn't make sense to draw the inverse function when you don't need to. And we're going to do an example for that. Go straight into the example and we'll go through that there. So for this question, we need to find the inverse of the function, where we've got the function going from 1 to infinity towards all real values, where the function is f of x equals to x minus 1 all squared plus 4. We also need to state its domain and range. Now typically if a question says to find the inverse, it's implied that you need to find the domain and range, but typically if they're asking for the domain and range, they will ask to state the domain and range. Now right off the bat, we know that this section of our function notation right there tells us our domain. Okay, now we know off the bat that our domain is specified by that, which means we can actually draw our graph. Before I get into any of the inverse algebra, I'm going to go ahead and just try and draw our graph here. So I'm going to try and draw this as neat as possible. I've got my function, which is going to be f of x equals to x minus 1 all squared plus 4. Given that I know that the domain is between 1 and infinity, I'm not going to bother drawing the left-hand side. I know my turning point is going to be, and I'll write this up here, turning point is going to be 1, 4, just based off my understanding of the turning point. So that's 1, and let's say that's 1, 2, 3, 4 up here. And so we have our starting point up here. As I go towards the right, remember our function goes from inclusive 1 to infinity, positive infinity, right? So as I increase, my function is going to look like this. So this right here is f of x, where f of x equals to x minus 1 squared plus 4. I'm just going to write f of x for us here. So we've got f of x there. Now keeping in mind that our domain is 1 to infinity, equals to 1 to infinity, obviously not including infinity because infinity is a concept, not a number. There we go. I have my range, which is going to be, and if you think about it logically, my range has to be from the smallest value of y to the largest value of y. With that in mind, I know that my range is going to be 4 up until infinity. Because this is my smallest point, I know that my y value is going to go from 4 all the way into infinity. So right off the bat, I know that for my function of f negative 1x, the domain is going to equal to 4 infinity, because I'm switching them around. And the range of my inverse function is going to equal to my 1 infinity. Now all that's left is to actually find the value or the expression for the inverse function. To do that, I'm going to replace f of x by writing y. So I'm going to write inverse over here so that we can see. I'm going to write y equals to bracket x minus 1 squared plus 4. That's just from up here. Next, I'm going to go ahead and actually switch and inverse it. So I'm going to get rid of the x over here. I'm going to get rid of the y over here and switch them around. So x, y. With that in mind, now all I have to do is take away and actually try to get y by itself. So x minus 4 equals to y minus 1 squared. I'm going to square root both sides, so I get square root of x minus 4 equals to y minus 1. Remember, if we square it, something it has to be plus or minus. And then I'm going to add 1 on both sides. I'm going to switch it around as well. So we get y equals 2 plus or minus square root of x minus 4 plus 1. Now this will be revision for some of you, but you can write it as that. Or you can write it as positive 1 plus or minus square root of x minus 4. And that's it. So we've stated our inverse function, and we've stated our domain and range. Hopefully that helps. Best of luck with exercise 5G.